Hello learners, my name is Ayushi Mittal and today we are back with another LEETCODE weekly question named Valid Binary Search Tree. So let's see what this question says. Question says that the given root of a binary tree determines if it is a valid binary search tree. A valid binary search tree is defined as follows. The left subtree of a node contains only nodes with keys less than the node's key, and the right subtree of the node contains only nodes with keys greater than node keys. Okay, and both the left and right subtree must also be a binary search tree. ठीक है? Okay, let's see with an example. This is an example 213. In this, the left node of the root is less less than root value, and in this right root the right node's value is greater than root value, so the output is true. Okay, so let's see another example. Another example says that 5 is a root node and 1 is its left node, which is less than, so it is right. Let's see to the right of the root. Right no, right node is not greater than the root, so it's not a BST. So we return the false. Okay. So the problem is how we can do this question, right? So first of all, we should see if we write, suppose we make this, once more, and suppose if we write it in order traversal. Okay, so if we write it in order traversal, then what in order traversal says? Left node to the node and then to the right. Okay, so if we do the in order traversal, the traversal will come out to be 1, 2 and 3. Okay, so this is the in order traversal, and if we find out the in order traversal of this one, so what will be the in order traversal? 1, 5, 3, 4, 6. Okay, very fine. Let's take one more example over here. Let's take 3, 1, 0, 2, okay, 5, 4 and 6. Sorry for the handwriting, guys. Okay, so if we write in order traversal of this one, then what it will come out to be? 0, 1, 2, 3, 4, 5, 6. Okay, so from this I can clearly observe that if we and if we find out the traversals, it is sorted array. The traversals is sorted and this is also sorted. So hence we can hence we can find our BST. Hence we can find a BST by using in order traversal, and its time complexity will be order of n, and the space complexity will be order of 2n, which is almost similar to order of n. But here is the problem that we are using array over here. We have to store the elements in some array or linked list. So that will take another extra space. Okay. So to reduce that thing, we can we can use another way of solving this question, which is, so the basic thing we want is we'll try to traverse the entire tree and make sure that every node in the subtree is valid binary search tree. And if it is, then we return true. If it's not, then we'll return false. Okay, so we can do this with the help of using maximum and minimum. Basically, we will try that the tree node, the node's value lies between both of them, and if one of them is, suppose maximum is null, then it should be greater than minimum. And if minimum is null, then we'll try that the node will be less than the maximum value. Okay, how we will do it, Ayushi? Okay, we'll see. I have write this code for you so that we can see here when we will be our root node, minimum will be null and maximum will also be null, obviously. Okay, because we don't have any of them. Here we have written if maximum is not equal to null and root dot value, here maximum is null and minimum is also null. So we will go directly to this step. What this step says, go to the root dot left and minimum will be null and your maximum will be root node, that is 3. Okay, and if we go to this one, if we see this line of code, this says that minimum is 3 and maximum is null, right? So why we are doing this? What is our main focus of doing this? We want to see that we know that in BST this left node should be less than the root node and the right node should be the greater than the root node. So this is the maximum node and this is the minimum. The root node here is maximum and root node here is minimum. Okay. If we go further, we'll see that we go in on here, the minimum will be null and maximum will be 3. Now, okay, here we'll check that if maximum is not null and root dot value, that is 1, is greater than equal to maximum dot value, that is 3. If this is a thing, if here this is not a thing, that's why we're not going and returning false. Okay, so it's not working here, and so we'll check for minimum. Minimum is null, so we will move on and go to this node. Here minimum is null and maximum is 3. 3 is greater than 0, so we'll move on and check for this one also. For this one we have minimum is equals to 1 and maximum equals to 3. Okay, so here what we have discussed is it should be between minimum and maximum. So it is true. Okay. So it is true for left sub node, left subtree. Now we'll check for right one. Right one says for this one the value is minimum is 3 and maximum is 5. This is between 4, 3 and 5, so it is also valid. Now we'll see for this one. Here minimum and we'll see maximum. So here minimum is 5 and maximum is null. So your value should be greater than minimum value, which is true here. So this complete tree is BST. Okay. But if okay. So but we haven't seen anything which comes into this node, because if it will come into this node, we will return false. Okay. So like in this one, suppose we are here, minimum is null, maximum is also null. If we come to the left subtree, minimum is null and maximum is 5. Okay, so here it is right. Here if we'll check, minimum is, so here max is equals to null. Okay, so this is greater than minimum, so it is right. So we will check for our uh, so we will check now. Now we will check for its child nodes. If we check for this particular node, we'll see that minimum is equals to 5 and maximum is equals to 6. Then we can clearly see that this node should be in between 5 and 6, and it is less than minimum. So this will clearly return false. Okay, so here we will return false, and this will this is that's why is not a BST. It is not the BST. Okay. So now let's see the code over here. This is code when we can use in order knowledge, in order function knowledge. Here I have implemented in order, and then I have seen that if it is sorted, then return true, and if it is not sorted uh, in it is not sorted in increasing manner. If it is not sorted in increasing manner, then we will return false. Okay. Here I have implemented in order, as I say, left node, root node, and the right node. We have done that only. Left node, when we have to go to the node on we are adding that into our array. Okay, and then to the right node. This is method 1, in which we are taking an extra array, but we can make it more efficient, as I said, by using this particular method. This is more efficient than the first one. What we have done in this, we have used minimum and maximum over here. If minimum is not null and root dot value is less than minimum dot value, then return false, because the root value cannot be less than minimum value. As I said, the value will be between, if the value is between is between minimum and maximum, then it's okay. But if it is not, then we will return false. Okay, so here we have sorry. So here we have checked for both the values, the minimum and the maximum. And if these are if this is not false, then we can return the whole root left node and the whole right left node. And here we have used and, because we want both of them to return true. If both of them are returning true, then only we'll return true, but if not, then we'll return false. So thank you so much for watching the video. Please like and subscribe. Please smash the like button and subscribe to my channel. Till then, we'll I'll see you in the next one. Till then, bye bye and keep coding. Bye.